Hello lovely students out there, welcome to your favorite YouTube channel, Toma Chang Tutorial. Myself, Kishan Kulum, and today we will discuss about Boyle's Law. A very famous scientist named Robert Boyle. Robert Boyle found out the relation between the pressure and volume of gas in the year 1662 and thus established his famous gas law, and that law is called Boyle's Law. Boyle's Law. Let me quickly write the statement of the law and proceed further. At constant temperature, the volume of fixed mass of gas is inversely proportional to its pressure. Let me read the statement. At constant temperature, the volume of fixed mass of gas is inversely proportional to its pressure. The first thing what we should keep in mind while learning Boyle's law is temperature and mass of the gas is constant. Temperature is constant and mass of the gas is also constant, which means temperature should not change throughout the experiment and mass of the gas also should not change throughout the experiment. Okay, before going in depth of the Boyle's law, let me tell you the concept, the basic of mathematics, the rule of mathematics from the chapter called variation. If I write this, what does this mean and how do you read this? A varies B. This can be read as A directly varies with B, or A is directly proportional to B. And what does this mean? If the value of A increases, then the value of B will also increase at the same time. And similarly, if the value of A decreases, the value of B will also decrease at the same time. But what if I write A proportional to 1 upon C? Here you can see C is in the denominator. How do we read this? A is inversely proportional to C. A is inversely proportional to C. This means that if the value of C increases, then the value of A decreases at the same time. And if the value of C decreases, then the value of A increases at the same time. Just the opposite of direct proportion, okay? I hope you got this. Now, what if I replace this sign of variation with equal to sign? I replace the sign of variation with equal to sign, then I need to introduce a constant K. Okay? And this K is called variation constant. Variation constant. Or you can also call it proportionality constant. Here also you can introduce a constant. By replacing the sign of variation, we write equal to and introduce a constant, and then C is in the denominator, we write as it is, where K is variation constant. Okay, I hope you got this. Now let us move to the Boyle's law, our main topic. To understand Boyle's law, let me draw a cylinder fitted with a freely movable piston. Okay, this cylinder is fitted with freely movable piston. Actually, this cylinder was developed by a very famous scientist and his name was Robert Hooke. Robert Hooke. Okay, not Captain Hook, it's Robert Hooke. Forget about Robert Hooke, let's come to the point. This is a cylinder fitted with a freely movable piston. You can move the piston up and down by applying pressure or releasing pressure. Okay, before going to this, let me tell you, here is a bucket of water and the capacity of this bucket is 10 liters and this bucket is full with water, 10 liters of water. Okay. Now, can you apply pressure and compress the volume of water? Can you apply pressure and compress the volume of water? The answer will be no. You cannot compress liquid by applying pressure. But it is different in the case of gas. If you apply pressure, you can compress gas. That's what I'm talking about. That's what Boyles Law wants us to know. And here, suppose you apply the pressure P1. When you apply the pressure P1, you compress with the pressure P1, the volume was this much. Let us say the volume was V1. When you applied the pressure P1, the volume was V1. Let us suppose. Now, when you increase the pressure here by compressing the gas, when you increase the pressure, let us say you applied with the pressure P2 and this pressure P2 is greater than the pressure P1, okay? Here the pressure was P1, the volume was this much. Now you applied more pressure. That means P2 is greater than P1. When you increase the pressure, the volume of the gas is reduced to V2. Say the volume of the gas here is V2. Now in the third case, let me draw another cylinder. The same cylinder in the three cases, okay? Now here, this is the piston and this is the handle of the piston, okay? When you applied, let us say when you applied with pressure P3, means P3 is even lesser than P1 and much lesser than P2. You didn't apply more pressure, you let the pressure go up. You let the piston go up. You didn't apply with more pressure. When the pressure was very small, the volume became very large. That is V3. We suppose this volume as V3. Which means when you increase the pressure, volume reduces. When you decrease the pressure, volume increases. The simple concept Boyle's Law wants to let us know is when you increase the pressure, volume increases, and when you decrease the pressure, volume increases. But the main topic here is temperature and mass of the gas should remain constant. Let us come to the point. Let us say mass of the gas in the first cylinder is m gram. Okay, m gram. The mass of the gas should be m gram here also, and the mass of the gas should be m gram in the third cylinder also. Actually, these are same cylinder, only the pistons are up and down by applying pressure and releasing pressure. Mass of the gas should remain constant throughout the experiment. Mass of the gas should not change, which means you cannot allow any gas from outside to enter the cylinder so that the quantity of gas in the cylinder may increase, or you cannot allow any gas from the cylinder to escape out of the cylinder so that the mass of the gas or the quantity of the gas from the cylinder may decrease. Mass of the gas should remain constant, gas should not be allowed to enter inside, and gas should not be allowed to leave from the cylinder, okay? And the second thing is, temperature should also remain constant. Suppose T degrees Celsius is the temperature here. T degrees Celsius means it can be 5 degrees Celsius, it can be 25 degrees Celsius, okay? Whatever be the temperature, T degrees Celsius is here. The temperature in this gas is T degrees Celsius, means temperature here should be also T degrees Celsius and temperature here should be also T degrees Celsius. Temperature should remain constant throughout the experiment. Temperature should not vary or change, okay? Which means no extra heat energy should be allowed to enter the cylinder and no heat energy from the cylinder should be allowed to escape from the cylinder. As you know, when heat enters the body, the temperature of the body rises, and when heat leaves from the body, the temperature of the body falls. So, no extra heat energy should be allowed to enter into the cylinder, so the temperature of the gas may rise or no extra or no heat from the cylinder or the gas should leave the cylinder so that the temperature of the gas may fall. Temperature should remain constant throughout the experiment and mass of the gas would remain same throughout the experiment. In that case, if you apply more pressure, volume reduces. If you apply less pressure, volume increases. Or you can also say V is inversely proportional to P, which means if you apply more pressure, volume decreases. As I told you earlier in the concept of mathematics, if P increases, V decreases. If P decreases, V increases. This is what exactly Boyle's law tells us. Now let us quickly move to the mathematical expression of Boyle's law. Mathematical expression of Boyle's law. Boyle's law, according to Boyle's law, we know that volume is inversely proportional to pressure when mass and temperature of the gas are constant. Okay, we understood this. When mass and temperature of the gas are constant, volume of the gas is inversely proportional to pressure. If pressure increases, volume decreases. If pressure decreases, volume increases. Okay, now we replace this sign of variation with equal to sign and introduce a constant. V equal to K into 1 upon P. P is in the denominator, so we keep P in the denominator itself. Or now we multiply this P with V, because P is in the denominator, we can cross multiply it. P into V is PV equal to K into 1 is K, which means the product of pressure and volume is constant. K is constant. The product of pressure and volume is constant. When you multiply pressure and volume, you get constant, which means if you increase pressure, volume also changes, means volume decreases. If you decrease pressure, volume increases. When you change pressure, volume automatically changes, but the product remains constant. Here, let us come to the point here again. When you increase pressure, volume changes. When you decrease pressure, volume changes. But when you increase pressure, volume became small, and when you decrease pressure, volume became large. Let us take an example here. Say P1 is 4 and V1 is 5. Here P2 is 10 and V2 is 2. Here P3 is 2 and V3 is 10. Okay. P1 is 4, V1 is 5. P1, V1. The product of P1 and V1. When you multiply P1 and V1, you get 4 into 5, 20. Here pressure is very much, so pressure is 10. Volume is very small, V2 is 2. So when you multiply P2 and V2, you got 2 into 10, 20. Here pressure is very small, P3 is 2 and V3 is very large, volume is very large, so V3 is 10. When you multiply P3 and V3, we got 2 into 10, 20. This is just an example, it's not always like this, but though you change the pressure, volume also changes, and the product of pressure and volume, the magnitude of the product of pressure and volume remain 20 in this example. This means whenever you change pressure, volume also changes, and the product of pressure and volume will always remain same, which means the product of pressure and volume is always constant. From here you can say, therefore, P1 V1 equal to P2 V2 equal to constant. Okay, this is the equation of Boyle's law. Boyle's law equation. This equation is called Boyle's law equation. This equation is called Boyle's law equation. When you change pressure, volume also changes. So product of pressure and volume is always constant. P1 V1 equal to P2 V2 equal to P3 V3 equal to constant. Okay. Now let us do one numerical problem from the Boyles law to better understand. Question: the volume of fixed mass of gas at 25 degrees Celsius is 25 degrees Celsius and 100 cm of Hg pressure is 80 ml. If the volume of gas is expanded to 160 ml, keeping the temperature constant. Find the pressure of the expanded gas. Okay, this is the question. The volume of fixed mass of gas at 25 degrees Celsius and 100 cm of Hg pressure is 80 ml. If the volume of the gas is expanded to 160 ml, keeping the temperature constant, find the pressure of the expanded gas. First of all, what we need to understand is mass of the gas is fixed and temperature is also constant or fixed. Mass of the gas is fixed and temperature is fixed, which means this question is from Boyle's law, no doubt. Okay, now the second thing, the main concept of the question, let us understand. Mass of the gas is fixed and temperature is fixed. We understood this. The second thing is, at 100 cm of Hg pressure, the volume of gas was how much? 80 ml. When the pressure of the gas was 100 cm of Hg, the volume of gas was 80 ml. Now, the question is asking, at what pressure the volume of the gas would be 160 ml. Okay, let us do this. Since P1 is 100 cm of Hg, pressure is 100 cm of Hg, V1 is 80 ml, P2 is not given to us, question mark, V2 is how much? 160 ml. 160 ml. When the pressure of the gas was 100 cm of Hg, volume of the gas was 80 ml. At what pressure the volume of the gas would expand to 160 ml? You can see here the volume of the gas is doubled, 80 ml to 160 ml. Now let us do this. This is a very simple question, and you can do other similar type of questions by applying Boyle's law. From Boyle's law equation, from Boyle's law equation, we have P1 V1 equal to P2 V2. This is Boyle's law equation. We have deduced this earlier. So let us put the value. P1 is how much? 100 into V1 is how much? 80 equal to P2 is not given to us, question mark, and B2 is how much? 160. This is simple mathematics. 100 into 80. Now let us bring this 160 to the denominator in the left hand side by cross multiplying it. P2 in the right hand side as it is. This 0 and this 0 got cancelled. 8 1s are 8, 8 2s are 16, 2 1s are 2, 2 5s are 10, 2 0s are 0. So we got P2 equal to 50. P2 means how much we got? 50 cm of Hg. When the pressure was 100 cm of Hg, volume of the gas was 80 ml. When the pressure is 50 cm of Hg, the volume of the gas is 160 ml. The question is solved, but what I want you to understand is when volume was 80 ml, pressure was 100. Okay, volume is double to 160 ml. What happens to pressure? Pressure is halved. Means when volume increases, pressure decreases. We know that when volume increases, pressure decreases. Volume is increased from 80 to 160. How much did it increase? Doubled. So pressure should be halved. Pressure was 100 cm of Hg. Now pressure became 50 cm. Okay students, thank you so much for today. We will meet in the next class with the graphical representation of Boyle's law. Till then, stay safe, stay happy, and hey, please don't forget to hit the subscribe button and click the bell icon for notification for more videos like this. Thank you so much.